to all. I am Dr.C.Thamarai Chelvi, Associate Professor of Chemistry, the Standard Fireworks Rajaratnam College for Women, Sivakasi. In this module, we have to discuss about Lande equation. These are the learning objectives of the Lande equation. First we see the introduction, next we see the Lande equation to calculate the lattice energy. Finally, calculate the lattice energy using Lande equation. Lattice energy is an important concept to understand about the ionic compounds. There are three ways to calculate the lattice energy. First one, Lande equation. This is the theoretical approach. Second one, Kapuscinski equation. This is also the theoretical approach. These two equations are calculate the lattice energy without knowing the geometry of the crystal. Finally, Born-Haber cycle. This is an experimental approach. The Lande equation is derived from Max Born and Alfred Lande in 1918, derived from the electrostatic potential for attraction as well as repulsion. The electrostatic potential energy E pair between the pair of ions of equal and opposite charges E pair is equal to minus Z square E square divided by 4 pi epsilon naught R. Z is the magnitude of charge of the ion and E is the elementary charge. Elementary charge is E is equal to 1.6022 into 10 power minus 19 coulomb. Epsilon naught is the permittivity of free space. R is the distance between the cation and anion. This is the attractive force of the equation E. The next one is the repulsive term. Born and Lande suggested that a repulsive interaction between the lattice ions would be the proportional to the 1 by R power n, so that the repulsive energy term E R would be expressed in E R is equal to B divided by R power n. B is the constant scaling the strength of the repulsive interaction. R is the closest distance between the two ions of opposite charges. N is the Born exponent, that is the Born exponent value is between 5 and 12. It depends on the cations and anions. This is the final equation to calculate the lattice energy. This is the electrostatic potential for both attraction and repulsive forces, that is U is equal to minus Na into M Z plus Z minus E square divided by 4 pi epsilon naught R naught into 1 minus 1 by N. Here Na is an Avogadro number, M is the modeling constant. That modeling constant depends on the geometry of the crystal. Z plus is the numerical value for the positive charge cation and Z minus is the numerical value of the negative charge anion. And then E square is nothing but of elementary charge, that is 1.6022 into 10 power minus 19 coulomb. And then epsilon naught is the permittivity of the free space. R0 is the closest distance between the cation and anion. This is the N is the Born exponent, that value depends on the cations and anions. This is the range is 5 to 12. These are the expansions of each, and U is the lattice energy, N is the Avogadro's constant, and M is the modeling constant. The modeling constant depends on the geometry of the crystal. The value of the sodium chloride, the modeling constant value of the sodium chloride is 1.75 and the cesium chloride is 1.76, fluoride is 2.52, etc. The Avogadro number Na value is 6.022 into 10 power 23 per mole. and the Born exponent value for a helium ion configuration, n value is equal to 5. If it is a neon ion configuration, n value is equal to 7, and third shell electronic configuration, n value is equal to 9, etc. Using these values, we calculate the lattice energy. Here we compute the lattice energy of sodium chloride by using the Born-Lande equation. The given data is the modeling constant of the particular geometry of the crystal is 1.75, Born exponent n value is equal to 8, and R0 distance between the cations and anions equal to 283 picometer, and 4 pi epsilon naught value is 1.112 into 10 power minus 10 Coulomb square per joule meter. Using this value, we have to find out the lattice energy of sodium chloride. Substitute this value in the equation. U is equal to minus NaM Z plus Z minus E square divided by 4 pi epsilon naught R naught into 1 minus 1 by N. You substitute the value, finally we get the result. The lattice energy U is equal to minus 756 kilojoule per mole. So, using that equation we have find out the lattice energy. Thank you for visiting. Thank you once again.